Hello and welcome. Today we're doing a question from LeetCode called Find Pivot Index. This is again part of the LeetCode 75 playlist that we're doing. So what is this question? Given an array of integers nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. If the index is on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index. If there is no such index, return -1. So example 1, 1, 7, 3, 6, 5, 6. The pivot index is 3, so that's going to be right over here. Because the sum of every single number strictly to the left of it, so 1, 7, 3, equals the sum of every single number strictly to the right of it. So 5, 6. They both equal 11. Now example 2, we have 1, 2, and 3. No index actually fits this condition, so we output -1. And example 3, we have 2, 1, -1. The pivot index is 0 because to the left of 0 is 0, and to the right of it, this sum also totals to 0. And we have some constraints over here. Okay, so for this problem, we want to find the leftmost pivot index, where everything to the left sums to everything strictly to the right of it. So we're going to need to keep track of a left sum and a right sum. And since we want the leftmost pivot index, we're going to start from the leftmost point in our array. So say we have this example over here. Now what I want to do is define my left and right sums. So left sum equals 0 and right sum is going to be the sum of everything we have in our num so far. So that's just going to be sum of nums. Now as we iterate through, so for I in range length of nums, which means I is going to start off at index 0, we want to calculate our left sum and right sum. So right now, left sum is correctly 0, but our right sum is every single number in our input nums, and we don't want that. We don't want to include the current index we're on. So what I'm going to do is subtract from right sum. Right sum is going to be minus equals what I have in my index so far. So nums at index I. Now I want to check if left sum and right sum are equal. So if left sum equals right sum, I'm just going to return I. And I know this is going to be my leftmost pivot index because we're iterating from left to right. So in this case, I just have to return I. And if that is not the case, then what I want to do is update my left sum. So left sum is now going to hold what I currently have in my index. So nums of I. And to write this out over here as well, our left sum currently now holds 1, and our right sum equals 27, what we have from index 1 onwards. So now we just finished this statement. We're just going to keep looping through, updating our right and left sum, up until either we return I or we go through everything and we return -1. So to see this play out, we just finished that first iteration. We're going to go back in our for loop. So I is now index 1 and update our right sum. So right is no longer going to include the index we're on. That's going to be 20. And we can see that the sum of 3, 6, 5, 6 is 20 and the sum of 1 is just 1. So we make a check and we see that these two aren't equal. So we don't return I and we add to our left sum our current number. So this goes to 8. We go back in our for loop. I is now at index 2. And since left sum is correct, we just need to go ahead and update right sum. So we're going to subtract our current number from it, which puts it at 17. Again, these are not equal. We can't return. And we add our current number to left sum. Going back in this for loop, we're going to subtract our number from right sum. And now when we go check, left sum is equal to right sum. So we're going to return I. And that correctly points to index 3, which is this element right here, just as we were expecting. And if we had gone through everything without finding anything, we would have returned -1. So let's go ahead and submit this. And it is accepted. Now talking about space and time complexity. For time, we could potentially be going through every single element in our input nums, not finding anything. So our time complexity is going to be O of n. We're going to go on our loop n times if there are n elements in nums. And for space, we're only keeping track of left sum and right sum. So that's going to be constant, irrelevant of how big our input gets. So that's going to be O of 1. So we just went ahead and solved a find pivot index. If you have any questions whatsoever, let me know down below. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.